Have you ever traveled through time? We do it every day.
Asgardia is a country with a population of more than 1 million people from more than 200 countries on Earth. Asgardia gives everyone equal opportunities, no matter what their earthly status is.
It is possible to create and live in the future right now. Are you ready? Forward progress is the solution to the entire human race. Our mission is to bridge new horizons. In Asgardia, there is no limit to the universal development in the fields of technology, finance, and arts. Asgardia is a new space and digital economy which creates opportunities for the global economy. We deliver innovations. Do you want to get on board with us? We are developing various kinds of digital businesses, attracting them to the Asgardia platform that can be backed by the means of our umbrella, i.e. franchising of the Asgardia brand. We can not only attract investments into space programs from prominent institutional investors, but also affordable amounts from the citizens of Asgardia. We comprise of more than...
in progress.
Good day, good morning, good evening, good night, wherever you are. We are here in Asgardia all over the world, and today we welcome you in the first webinar of this year 0007 in Asgardia, or year 2023 in Gregorian calendar. Today we will be talking about one of the core missions of Asgardia. As you know, according to the vision declared by the head of nation, Dr. Igor Ashurbeli, the core mission of Asgardia is birth of the first human child in space. For this purpose, three main areas of research are being pursued by Asgardia: artificial gravity, protection from space radiation, and procreation in space. First pregnancy, first gestation, first giving birth in space. And that's one of the core science area where Asgardia is active. So today in this panel, I'm the host, Prime Minister of Asgardia, Lena de Winne, and the panelist experts are Egbert Edelbroek, the CEO and founder of Spaceborne United Consortium and member of Asgardian Parliament. He will be the key presenter today and will be talking about the mission, which will commence shortly. Professor Dr. Floris Woutz, he is the Minister of Science of Asgardia, and Mrs. Cheryl Gallagher, who is the Minister of Culture of Asgardia. We're so glad you're with us today. You can post your questions in Q&A session. We will do our best to take your questions. And for now, Mr. Edelbroek, please go ahead, tell us what's lying ahead of us.
Thank you for the warm introduction, Prime Minister Lena de Winne. I'm very excited to be here and to have the opportunity to explain our goals and our involvements and our progress. And I'm very happy that also the Minister of Culture and the Minister of Science are joining, because we're going to need their expertise. But I'm going to explain what we are doing in terms of Space Procreation Precursor Missions, which is all about eventually researching the partial gravity effects on embryo development, in this case, starting in low Earth orbit. Let me start with explaining which topics we'll be talking about in the next, let's say, 15 to 20 minutes. I will start to briefly summarize what we do at Spaceborne United and why that is relevant. Then I will continue to explain briefly how it started and how did we develop, how did we grow. And then I will explain who are involved in this activity in terms of which academic and also industry partners. I will explain what the ultimate goal is of what we do and which steps, which milestones are defined to reach that goal. I will also, of course, explain where we are right now on this roadmap and what will happen this year. There are all kinds of ethical and legal issues also related to our work, so I will also explain how we deal with them. I will not be using PowerPoint slides. I will use two short scenes of an animation that will illustrate the IVF in Space mission, and one brief video showing the hardware development that is realized by our implementation partners. Altogether, those will be less than 4 minutes. So let's start looking at what it is that we do. We have three main activities. We started with research, researching the conditions for human reproduction in space. And reproduction is not just one event, obviously, it consists of different stages. So we also research those different stages of reproduction in space. The second thing that we do is we translate the outcomes of that research into missions in which we can research those different stages of reproduction, and those missions together form a missions program. I will elaborate a bit more about that later. And the third thing that we do is we translate the research outcome into biomedical equipment that is needed for those missions. So reproduction is a 9-month cycle, and we are focusing on the first steps. So the last couple of years and the next couple of years, we will still be focusing on the first part of reproduction, the conception and the first few days of embryo development. So IVF, in vitro fertilization, is a big part of that. And our biomedical device that we are developing is enabling IVF in space. And IVF is part of what is called assisted reproductive technology. And the device that we are making is called ARTIS. And our mission is also called Mission ARTIS. And that stands for Assisted Reproductive Technology in Space. So this requires a step-by-step approach. And we're talking about unmanned missions. The IVF that we enable will happen in unmanned biosatellites. It would be very medically and ethically irresponsible to realize IVF in space by sending adults into space and cause natural conceptions. We need to study a lot before we are ready for something like that. So that is important to understand. So that brings us to the question, why would we do this? Why is this relevant? We support the goal, exactly similar to Asgardia, obviously, that humanity should be able to live in space, in habitats, in low Earth orbit, and eventually also on other planets or on the moon. So that requires learning how we can safely enable reproduction in space, because this will not, it will be very unlikely that this will happen in Earth gravity. And in most cases, it will be in lower gravity, or they call it partial gravity. So it's very important to find out what the effects of this lower gravity are, especially on developing embryos. So we are trying to find out what partial gravity will be safe for embryo development in space. I think this would be a good moment to show you two brief scenes that give you a better idea of what we are talking about before we move on. And so I'm going to share my screen for a second and start one of the scenes. Just checking if you can see it.
Yes, indeed.
And now I will add the second scene.
Egbert, maybe you could comment in the meantime. What does this signify?
Oh, sure.
Was that a launch and deployment stage, I suppose?
Yes, so let me briefly stop the sharing. What you saw was the rocket that is carrying the biosatellite that I was mentioning. And this rocket is in this scene already launched into space, probably from Canada, where this company, the Space Ride company is. And you saw that the rocket divided into a second stage, and the first stage did its work and was then sent back to the atmosphere. And then the second stage of the rocket opened, and you saw a capsule coming out of it. And in that capsule, that's where our IVF in space device will be operational. And that is what I'm going to show you in the second.
And what kind of a flight is that? Is it suborbital flight, ballistic flight, low Earth orbit flight?
Of course, that's an important question. This is going to be a 5 to 6 day mission in orbit around the Earth. So this is an orbital mission that we are working towards. I will share the screen again. So in this second scene, you could see the actual IVF process, the sperm cells mixing with the female reproductive cells, and they were staying inside this disc. So the good thing about this new IVF technology is called IVF on a chip or IVF on a disc. We only need a very small space to make IVF happen in space, and it is done by using a disk, because we want to generate artificial rotational gravity, because we need the embryos to experience normal Earth-like gravity. And perhaps Floris Weitz will elaborate on that if there are questions, because he's an expert on this field. So that is about that gives you some idea of important parts of this mission.
How long will be the flight?
The flight will be 5 to 6 days, because that is the time that we want the embryos to develop. And after that time, human embryos at least need to go back in the natural womb for further development. So until now, we can do a 5 to 6 day flight.
So for all this duration of 5 to 6 days, the embryos, the cells will be staying in the rotating disk, which you showed, to sustain the artificial gravity while being in space. Is that correct?
Exactly. The embryos will be developing for all that period inside that disk in the reaction chambers.
And they're going to land after 5 to 6 days, and the idea is that they're recovered. What happens with them afterwards?
Exactly. So this device that you saw flying is a re-entry device with a heat shield and an included parachute. It can do a deorbit burn to get back to the surface of Earth safely, and the embryos will be protected for that quite violent process. They are recovered, and then they will be examined for any events that happened in space, and if the embryos are affected by space radiation or by other elements of the mission.
So Floris, you wanted to comment something?
Yeah, I just had a question regarding the temperature. So it will be in an environment of controlled temperature also?
Yes, this is a simplified, let's say, artist impression. You only see one important part of the disk that really shows the IVF process. But in reality, there will be multiple layers of that disk and a climate control system that is not really shown in much detail. So it will be exactly, or at least as similar as possible to normal IVF procedures on Earth. So also in the right temperature.
And the spermatozoa, are they frozen when they are, let's say, lifted or launched, or what is the temperature of the eggs, of the fertilization material?
Yes, this is the approach for IVF, where freshly harvested female reproductive cells will be combined by sperm cells, and that means that they are not frozen before the mission. Because if we would choose that approach, which is also done in IVF clinics on Earth, then the cell membranes of the female cells would harden, and then the natural fertilization could not happen. Then the only way would be to use what they call the ICSI technology, where the needle inserts a sperm cell into the egg, and that is very complicated to automate and to make that work in space. So we work with a quite ambitious time window, where we only have about 6 to 8 hours after harvesting the cells from the natural mother into bringing them into space and having them fertilized by the sperm cells.
Okay, Egbert, is there still some video you are planning to show?
Yes, I can show it right now. I can also elaborate on how we started, but I can also now use the video, whatever.
Let's go ahead with the video to be on schedule.
Yes, okay. Let me share the screen again. In the video, you will be looking at, well, myself visiting Cranfield University and a company spin-off from Cranfield University, where the space capsule in which we will have the test flight next year and where the other hardware elements are developed. But let me start the video.
Just for our viewers, I would like to mention you have seen the impressive list of institutions in the last picture of the video. These are all members of Spaceborne United Consortium, and everybody are doing their expert work to make sure that the scientific mission of Spaceborne is at the highest level of scientific standards. So anything else you want to comment about the video we have just seen, Egbert?
Yeah, I think most people would have recognized the actual physical disk that was spinning for a first ground-based test. It was the same disk that will be a further innovated, optimized disk will be in the test capsule, and that will actually be going on board a rocket this year in April. In the next month, in February, I will be going with these people to Canada to join what they call a payload integration test, which means that the capsule that you saw in the video will be mounted on the rocket from SpaceRide, and they will connect all the cables, and they test the communication between our device and the rocket and the ground station. And those kind of elements are part of the integration test. And then if we find details, we can still fix some things. And then about 6 weeks later, in April, it will actually launch during a suborbital test flight. So that's, I think, something exciting to also share.
So, dear viewers, please follow Asgardia News. We will be, of course, extensively covering the preparation, the launch integration, pre-launch integration by Egbert Edelbrook of this payload. And when the date of the launch is clearly known, of course, we will be covering it and we will be giving exclusive commentary to that. Still, for this, please stay tuned to the Asgardia News. And in the meantime, we will proceed. So what you have seen now is the state-of-the-art, the upcoming futuristic research, which will make in the future possible to have reproduction of humans in space. In the meantime, we have received one question from the audience. Can you guarantee that space human reproduction is 100% accurate and safe? Space flight is a test flight. Nobody can guarantee anything in space flight. Therefore, we're taking baby steps and all the precautions and testing one cell at a time, literally, in order to make sure that when it comes to human reproduction, it is safe for humans. The ethical aspects are extremely important, and we probably will create a dedicated webinar to talk about them. They're extremely interesting and extremely important. This is about reproduction of humans, but of course, humans are the top of the range. In order to come to human reproduction experiments, there have been also other reproduction experiments in the past. Professor Floris Woutz here is a prominent researcher in human spaceflight physiology, and I would like to ask Floris if you can give us a brief overview. What other reproduction experiments have been done in space? What allowed us to be sitting here today and hearing what Egbert is doing to achieve reproduction of human cells?
Thank you. Well, actually, there are not so many projects being done. There is a recent review of the entire literature, which actually just said it comes down to 27 publications since the beginning of this type of research. If you would compare that with, for instance, if you would type in Alzheimer's research, you would find almost 1 million publications. So 27 is very few. And most of these experiments are actually even just done on Earth in models for spaceflight, like hind limb unloading models, where they test rodents and what is the impact of simulated microgravity on rodents. Very, very little human work whatsoever. And there are a few experiments in the Cosmos missions where they flew rats into space in the 80s. And they flew the rats into space. They stayed there 19 days. And they were mating them, or let's say the experiment was to mate, to let them mate and see for the pregnancy of the female rats. Some of were fertilized, and they could investigate the early gestation of the rats in space, but they showed indeed that there were definitely some alterations, and there was no much more work is needed to find out what is the impact of microgravity and in combination of radiation on particularly the early stage of gestation, because that's very crucial. And that's why it is so important that indeed the component of artificial gravity is introduced in the experiments which are planned, and artificial gravity was not a factor which has been introduced in the previous experiments. So all the experiments either are like frozen cells of male rats who have been sent to space. They stayed there 9 months and then they came back, and then they investigated if these frozen fertilization, the frozen sperm of the rats was, sorry, it was mice, if it was still viable. And indeed, these were still viable and gave, well, they were used for fertilization of female rats, and they gave indeed birth based, sorry, it was mice, based on the frozen sperm which stayed in space. So to a certain extent, some experiments show there is no effect, other experiments show that there is effect. So there's quite some controversy even within the scientific community, because there are, on one hand, very few models. There are very few species who flow. There were also what is called sort of like sea crustacea, which has been sent into space, sort of like snails, but then from the sea, which didn't show too much of alterations. As I say, the rat experiments were the most, let's say, close to what will be eventually being done, being indeed mating in space and then gestating babies, or let's say the species which is either mice, either rats, either other animals. So that only dates from the 80s and hasn't been done since then. So all the experiments done since then are just models, and very few in space. So there are many more steps to find out how we can improve and how are we going to measure and how are we going to evaluate the different steps. So as I say, very few research has been done, and most of them, well, all of them were without artificial gravity.
But Floris, just in simple terms, for people like me who are not scientists. So mice got pregnant in space and afterwards gave birth on Earth. Did I understand correctly?
It were rats, actually.
Rats, okay.
So the rats, yes.
One of those.
And they gave birth on Earth, but the pregnancy and the what is it, giving birth by itself was hampered and was much longer because for the simple reason that being in microgravity, the abdominal muscle, which are needed to push out the small rats to give birth, so they were underdeveloped because of the microgravity. So that by itself was lengthening the giving birth itself, because of the simple reason that going to space, as we all know, affects the muscle, and so the muscle will get much weaker. So
since the 80s, somewhere on Earth, there are rats who are born after having been conceived in space. Is that correct?
Correct, yes, but they didn't survive long.
But there are no longitudinal studies. It's not like that they're kept for generations and we would now know 40 years later, 50 years later, what's going on. It's not happening yet.
That wasn't so far done, yes.
Okay, so we can be actually quite safely assuming that there is no major mutation occurring because rats reproduce at very high speed, and since there is no new type of rats running around and nobody watches them and nobody can tell them apart, we can hopefully assume that it doesn't bring major dangers. Again, that's my very layman observation from what you just said and how I could interpret it. Am I correct?
Well, actually, it is indeed shown that in the early experiments, there is indeed gene changes. So that is why they want to, one of the countermeasures which they have been thinking of is gene silencing, because gene silencing is a tool, is a method, and I just also read it recently in a paper. It's a way of actually kind of like stopping based on nucleic acid elements which are brought into the material, so to just stop the gene expression actually. So that could be a tool to prevent the changes which were observed by some researcher after sending spermatozoa into space, and then because that has been looked at, looking at spermatozoa in space, and indeed there was a hampered spermatogenesis, which means that there is less sperm being produced by the animals which were sent into space. There are a couple of experiments which all show either an effect, either no effect, and definitely the genetic expression is part of it. and that was hampered in some experiments. So there is a lot. So the three things which are absolutely important is the control of the radiation, because particularly in such an early stage, radiation definitely altered the DNA material. And as we all know, people on Earth who are in an early stage of their pregnancy, women are really kept outside of all possible radiation hazards. That's why people in the medical hospitals have to stop. I mean, like the nurses have to stop working in medical hospitals, because they may be involuntarily prone to radiation because of certain examinations which are going on in cancer research and radiotherapy. So that's for sure, radiation is an issue. And then the microgravity is an issue, as well as actually as a hypergravity, because to certain, that's also part of the experiment of Edelbrock, that the fact when the capsule is returning back to Earth, that it will be subjected to high Gs during the landing procedure. And I don't know what will be the Gs which will be the satellite exposed to, but that is also a part of it, which definitely impacts the spermatozoa and the early gestation. So that is also an influencing factor. And then, as I was saying, microgravity by itself is affecting. So I'm pretty curious to actually find out what is the G level which is being used during the mission, and what is the impact of the fact that if you have a rotating disk, that at the outside of the disk you have another gravity level that at the inside of the disk.
Egbert?
Yeah, legitimate questions, obviously. And of course, we need to protect the embryos when they have developed for about 6 days for the violent re-entry procedure, because indeed such a procedure will generate about at least 5 to 6 Gs. That is 5 to 6 times what we are used to on Earth, which is crazy if you would expose living embryos to that. And that is also a reason why we cryogenically freeze the embryos before we start the re-entry procedure. So that will protect them from all these G forces and other vibrations.
So these are scientific solutions which are being technical and now implemented to make sure that the samples are returned and can be used for further research in order to advance our knowledge. A couple of questions which came in refer to the ethical aspects of the human reproduction in space. Before taking this question, I would like to ask our Minister of Culture, Cheryl Gallagher, to share her ideas. Why is it important that humanity should live and reproduce in space? Cheryl also authored an article in the recent Room magazine. If you are a resident of Asgardia, you receive an electronic version of Room magazine as a benefit of being an Asgardian resident. So I encourage all of you to read Cheryl's article to look deeper into what we're discussing today. Cheryl, please go ahead.
Thank you, Prime Minister. Obviously, all topics around child development and childbirth are sensitive to everyone. It's critical to everyone on Earth. The frank reality is, with regard to space exploration and space settlement and the successful establishment of life in orbit, we're going to remain tethered to the planet if we are not able to achieve one of these goals. And it's indeed, in terms of long-term survival, it's just as important to be investigating this in tandem with all the explorations on gravity and the other things that we're going to need out there, our sources of air, of water. It's just as critical in its own way, maybe not in the shortest term, but in terms of as we establish ourselves farther and farther out. And so I find Dr. Edelbrock's research and his approach it's both extremely courageous, extremely ambitious, and kind of pushing that needle farther down the road in a big way. Just as, you know, one of the things that Dr. Vitz pointed out was that there are gaps in the research on reproduction, and in terms of at a minimum, but the fact that all these things are happening at the same time helps ensure a faster and better outcome in the end. I have more comments about that, but maybe for another question.
And Egbert, would you like to comment to this aspect? Why is it important that humans ultimately can reproduce in space?
Of course, yeah. So there's two sides of this. One side is about addressing threats. There are these threats to human life on Earth, climate change. I think many people are aware of the common threats. Artificial intelligence might go in the wrong way in a few decades. And eventually, in millions of years, even the sun will end its life cycle, and we will have to move. So eventually, we need to address this threat, and maybe even a lot sooner than we think. Maybe in the next couple of 100 years, or in the few next decades, even some person will push the wrong red button and start a nuclear war. There are these threats to human life on Earth that can also be addressed by becoming a post-planetary or multi-planetary species. So that is one side of this challenge, and the other side is there are also a lot of very interesting opportunities that we can seize actually by becoming post-planetary or multi-planetary. There are these hidden the hidden potential inside our genome. If you allow people to live in a different environment with different gravity levels, different atmosphere, different radiation levels, our genes will adapt, and it will create opportunities to unlock hidden human potential. Further, humanity and different civilizations have been able to achieve very good things. We've been able to reduce all kinds of diseases and even eradicate some. We've been able to reduce poverty levels, and one day we will be able to eradicate that also. There's so much potential in humanity itself, and if we want to keep using that and to keep providing opportunities for that, we need to protect ourselves and also create human settlements on other planets. I think those two, both averting the threats and seizing these opportunities, those are the key things for us.
If I may add to that, actually, we don't have to look far back in the past, and actually it is currently still ongoing, but the pandemic was a very nice example of something which is sort of like threatening everybody on Earth. And it was a very gentle virus, but suppose this virus would be like 10 times more lethal, then it suddenly is not science fiction anymore, that we may have to escape to a certain moment. I mean, it was just like, it is still ongoing, the coronavirus. So I think it was a nice wake-up call for people who were thinking, oh, it's all something for the future. No, it can be much closer than the 6 million years for the solar system to exist further.
That's indeed the goal of the Asgardian research, the core mission of Asgardia, to achieve infinite survival of human species in space in order to prevent extinction of humans as biological species on Earth in case or whenever, hopefully very late in the future. But I was not prepared to your few decades apocalyptic forecast. So hopefully many, many thousands and millions of years from now, and we have time still to do it thoroughly and slowly and properly, humanity will be able to live between stars. To have a better look at the mission of Asgardia, you can go onto asgardia.space, open the menu and open the brochure. There you will find a page, a spread, where you can see the roadmap of how Asgardia is planning to build a low Earth orbit station, which is called Asgardia National Ark, followed by the cislunar orbit station, and then followed by the star arc. This is the intention that Asgardia is living on various space stations, and those space stations are fit in order to provide artificial gravity necessary for the research and development and reproduction and protection from space radiation. We will, in any case, with Professor Woutz, be hosting webinars for artificial gravity later to specifically address this matter. But for now, we will continue about human reproduction. So, Egbert, would you like to answer a question? We are being asked who are the male and female humans whose reproductive cells will be used for fertilization? What is the criteria for selecting those contributors? Before we go any further, I will, of course, insist for the entire audience that in line with all the international laws, all the people remain strictly anonymous. But when it comes to the parameters, we will ask the expert to comment.
Yes, so it's actually a coincidence. Yesterday, we had a group meeting with Space United where our male fertility expert was explicitly summing up all the criteria for the male sperm donors. So I recall some of them, and I remember some of them anyway. So it's important that these donors, male donors and female donors, that they are healthy in various ways, both physically and mentally. And age is also a part of that. So there is an age range which is also different for male and female donors. We actually did our first semen analysis from the first donor candidate. Unfortunately, the quality, the motility is a technical term of the sperm cells was not sufficient. And of course, we want to have a very successful mission, and that needs the healthiest sperm cells and female reproductive cells. So, but it was very helpful for us to learn this procedure. And we are looking for both physically fit people, and that includes looking back at several generations, because sometimes diseases can skip a generation. So we will analyze a donor's sickness history a few generations back. And we will also assess their mental health, so to speak. We haven't. We still have homework to do there, but that's not a problem, because as you and Floris explained earlier, or at least Floris, working with human reproductive cells in space is a few steps ahead. We will first do missions with animal models, with mouse embryos, etc. So there is some homework for us to do there, but I hope this, in a nutshell, gives some idea about how we deal with these challenges.
Just a question: what is the age range which is allowed?
I remember for females it's 18 to 35, and that is because we start with the optimal situation. Eventually, we want space to be accessible for all people, so that range will be not that narrow, but because we want to have an optimal, successful mission, we have to start with working with the optimal candidates. And for that goal, there is a quite strict age range between 18 and 35 for women. I don't remember exactly the age range for men. I do know that IVF clinics on Earth recently changed and have a limit also for men, which is 45 years old.
Okay. And does it have to be fathers?
Good question. We will prefer, our IVF experts prefer people with what is called proven fertility, and the best proof, of course, is having children.
Yeah.
So basically, the best practices available on Earth are applied for space research, because this is common sense. And then we, of course, again, go into the ethical issues, which are very interesting. Just out of my curiosity, did you get yourself in private and without disclosing the names or faces, to talk to people who were chosen as donors or who actually volunteered to be donors. Do they know whose cells were selected, those 1 or 2 people, or 2 or 3 or 4? And if they know how they feel about it, or what motivates people to contribute their material to this research.
Yes, I was lucky enough to join, to have a few conversations with people that reached out to us because they had the ambition to contribute to space exploration and to space research, answering also the motivation question. And we had a lot of discussions about ethical topics because it will it's quite a responsibility to some people perceive also what we do as small steps in human evolution. So that makes the people that are involved, they could end up like in the history books, and the media will be very interested in who are they. And we need to protect them for all of that, because that's part of our responsibility. And even when we do the best that we can, there will still be a risk that there is some media journalist that is smart enough to still find some kind of leak. So we need to make these people aware of even that risk. And we, of course, talk about their motivations. And we learned also by having these conversations that there are that it's also very important to look at the family, other people that are close to this donor. They also have an opinion. They might also have concerns, and we want to address all of them. So it's very helpful to join these conversations.
So what's the core motivation? Just wanting to contribute to humanities research or something else?
The core motivation for the donor that I have been talking to recently was really to contribute to space exploration in general and to becoming multiplanetary as a species. And this person, fortunately, didn't want anything else. He didn't want to be in any publicity, because that is a factor that we need to check. We don't want donors for their aim for fame and fortune or anything like that. So we were happy that this person was trying to stay behind the scenes at all costs, so to speak.
That I find very commendable, because indeed being a donor is a private choice and private matter. It's not a scientific achievement. It's a contribution to scientific research. And that, of course, brings us to an interesting angle, which is even bigger than ethical aspects of it, the whole culture of humans living beyond planet Earth. And I would again ask Cheryl to comment further, because by living on Earth as a community, as Asgardia, we're building up Asgardia culture, which is capitalizing on the best there is. And we want to take it with us into space. We are not just taking care of physical survival of human species, we are taking care of survival of human civilization. And of course, civilization to a large extent defined by its culture. Cheryl, if you could please comment on that.
Yes, of course. One of the things that I think is what is being reflected in this conversation and in most of the conversations I hear in the greater space community is the deep care and the deep attention for the highest possible ethical and interrelational interactions, respect for the human being, and even when I'm watching the Spaceborne United's initiative, watching the care and respect even to the smallest level, like total respect for the gravity of what they're doing, not pun intended, but also the handling of everything and every aspect of it. And it doesn't take very long to realize just how nuanced and complex it is. It's not a dichotomous thing at all. It's very nuanced, and each level has its own level of complexity. The same thing can be said for the whole space community. Asgardia is not existing in a vacuum of space development. It's not, we have taken on this aspect of humanity's future in space as a special a special project. Children, healthy children born in a safe, sustainable manner in space as a special project, but it lives within the context of our overall mission of evolving to a higher level of living. And the fact that we will, that space is a completely unique environment gives us a great opportunity to maximize that possibility. We're in Asgardia, we're working in a matrix of space initiatives, and all of us are ultimately working in relative tandem together with the whole space community, regardless of each initiative's focus. Each innovation and discovery is building on the last, and the whole space community benefits and grows. On top of that, everything that we learn out there, because of how meticulously detailed the investigations are, all of the things that we discover have their applications back here on Earth and impact Earth in a very positive, constructive manner. So, so these relationships, that is just part of the natural environment of working in the space milieu. It's not so much a race to space. It's more like, whether you care to participate or not, it's more like a cosmic obstacle course in which all participants win together. And the best of results coming from these truly collaborative building relationships and problem solving that carries us all together to ultimate success in our goals. And so this dynamic of how we're working as we're growing into living in space, and as a space nation, Asgardia, plays constructively upon this key survival strength that humans have, and increases exponentially our chances for success. So, as the opportunities arise among space initiatives whose mission objectives, like Spaceborne United, are aligned with our mission, which is most of them, that attitude of building community support and collaboration, I think, is what's going to ultimately contribute to our success in this quest. Thank you.
Thank you, Cheryl. I would like to remind again all our viewers here online in Zoom or on Asgardia TV that Cheryl authored a big article in the latest Room magazine. All our residents have free access to Room, and I encourage all of you to scroll through Room and specifically to read what Cheryl has to say, and you will find out much more than what she just briefly presented about culture and space. Let's take more questions. So what's the time frame for an actual human birth in space? Dr. Shurveli defines Asgardia's mission as birth of the first human child in space in the coming 25 years. This was announced a couple of years ago. 25 years, basically quarter of a century. It's not the exact number of years, it's the range within which this is expected to happen. And this is the work which is being done towards this goal. How can we be sure that radiation did not affect the embryo at the DNA level? Egbert.
Yes, that's a very important topic. So one way of preventing radiation damage is looking at which orbits around Earth and which altitude above the Earth surface creates the safest radiation environment. And one detail that I can easily reveal is that we learned with extensive research with Cranfield University is that on the altitude of 230 kilometers, that is about 150 kilometers beneath where the International Space Station is orbiting Earth. On the 230 kilometer altitude, we will do our 5-day orbital missions, because in that area specifically, the radiation level will stay well under the norms for developing embryos in that way, they are safe for those during all of that mission. I don't know the exact inclination of that orbit, but you can understand that there are different places around the Earth that have different radiation intensities. And there are these areas where radiation particles are trapped, these anomaly areas, and we are avoiding those in any way. And it can be counterintuitive that sometimes you think, oh, you just need a lot of mass, maybe even like lead or something to protect against these radiation particles. But the problem is some of the radiation particles have so much energy, they will just pass through thick layers of metal, even in the International Space Station. And the more metal you put between whatever you want to protect and the radiation, that will cause more damage to the embryos than if you have less radiation protection, because the heavy energy particles, they will have a snowball effect on whatever material you use for radiation protection. This might be a little bit technical, but just to be more complete in my answer.
Okay, thank you. The next technical question also to you. Will there be cameras on the satellite for us to see what's happening with the eggs?
On several levels, we will be monitoring the experiments. The embryos themselves, actually on an individual level, there will be several micro cameras in another layer in that disk. So those cameras will monitor the embryo development during the 5-day mission. So we will be able to look at the embryo development, and there will be a camera overlooking a bigger part of the experiment so that we can check if the disk is rotating well and at the right speeds, etc. So there will be a few cameras that will provide very interesting video footage that we can probably partially at least live stream during the mission.
Okay, so you will be receiving video as experiment evolves?
Yes, and that's,
you will be monitoring it live.
Exactly, and that's also for a medical reason. We use the similar, what they call time-lapse technology, where IVF analysts can look at the embryo development with this time lapse, looking back at the different stages of development to determine the health and the quality of the embryo. So we are using a similar technology to also check on how the embryo development is progressing.
Okay, so I'm looking forward to that. I didn't realize you might be streaming live. But before we all got inspired, I don't think it will be a very animated observation. I think that cells merging is in itself a slow process, so it will be extremely interesting to see the resulting video you maybe produce later to show high speed. It's like they show how flowers blossom or things like that. That probably will be very fascinating product, but later after the mission is completed. Next question, is it necessary for humanity to reproduce naturally, or artificial insemination will be the only variant for survival of humanity outside of the Earth? I personally hope that both are available, because we are just taking human life just to a different location. But again, I will refer to the expert.
Indeed, the goal is eventually that people will be able to reproduce in a natural way, but to achieve that goal in the most medical and ethically optimal way, we need to study that process. And we can study it with artificial technologies, with assisted reproductive technologies. So it's only like a method of preparing for that goal, because most experts assume and work towards making natural reproduction possible.
But at the same time, we want to remember that we want things to be as efficient as possible in space. So while people may choose to have natural reproduction, it's excellent that the scientific development allows them to do so. We also want to be sure that if people choose to have artificial reproduction, that's also possible. It's one of the areas of development, including artificial wombs. But again, that would be a topic for a separate discussion. General question about radiation. Maybe Floris can help here. Do we know if at different altitudes the radiation levels are fixed or they can vary at the same altitude?
Well, as far as I know, obviously, and it's also valid for the International Space Station, it is still within the Van Allen belts, which are protective belts which are provided by the magnetic field of the Earth. As we all know, the Earth has a magnetic dipole with a north and a south pole, and so that generates a magnetic field around it, which is a protective layer for ionizing radiation coming from outer space. There is obviously still coming inside and approaching, and this is what we call the cosmic radiation, but it is much less lethal than if you would go out to, for instance, to Mars, where just staying on the surface of Mars is much more lethal if you don't have the appropriate protection. That's why one of the reasons why for the Mars settlements, the first approaches are to go underground so that you have protecting from that lethal outside radiation. So indeed, on the Earth, as far as I recall, I think in the ISS is 100 times more radiation than on Earth, but that is still within acceptable limits. And as far as I know, from the 550 astronauts so far who have been living in space, there hasn't been an increased cancer risk observed among this population. Obviously, it's a small population and it's difficult to make a generalization, but there are enough protective tools available at this stage for people within this low Earth orbit, as we say. So I think it is fairly safe to say that at that level, also given the current protective tools, that risk is not too high, but a very big but. It's about existing cells. It is about the existing life. And we all know that our cells, even for those people living on Earth, we have a recovery tool. And so we are regenerative. So the cells are continuously being damaged by radiation, but we recover. It's only when there is a level of radiation which is too far, too high, too deep, that the cells can't regenerate, and that's causing then diseases and so on. Now, as we are talking in this project of procreation in space, then we are at a very other level, because then it are still unique cells and very fragile cells. So I guess that the level of radiation which will be there even in low Earth orbit is still a big problem to solve. So we have to take totally different protective measures, because it's a totally different ball game if you have in the earliest days of gestation, where radiation can be absolutely lethal at the levels which is available there.
Thank you, Floris. And to complete our discussion, I will take a question which actually was the first one which came to my mind as I was listening to Egbert's first presentation. They are creating in this mission fertilized cell. So what happens with the embryo after it comes back to Earth? Is it going to be implanted into a uterus of a surrogate mother? And will this child be born? Egbert.
Yes, initially we had the ambition to place the embryos back after the first mission where human embryos are conceived, but we learn a lot in all this pioneering roller coaster, so to speak, and it's all about regulatory approval. There are these ethical committees. It's their job. They're doing a very good and important job to make sure that we are doing things in a step-by-step approach, and we need absolute safety before they will give regulatory approval for such a big step. So we will definitely not be able to place embryos back after the first mission with human cells. We don't know what it will take before we will be allowed to. And there's also interesting approaches that state that it might be unethical not to allow this because of all those threats to human life on Earth. We might not have enough time if we don't accelerate this kind of space life science, but that's a tricky gray area. That's not our job. We look at what is possible, and we understand the importance of ethical committees, and they will kind of determine the acceleration speed that will be allowed. That will be ethically responsible.
Okay, so I would now ask every panel member if they have any closing remarks, and we're coming to an end. Floris, do you have any closing remarks?
No, I'm looking forward for the future in this topic.
Cheryl?
Nothing except for continued success here. The pace at which you're working is really impressive there, Egbert. And I also appreciate the attention and the scrupulousness of your activities. So, keep up the great progress. It's awesome to watch.
Egbert?
Yeah, I just want to thank Asgardia and Cheryl, obviously, for the compliments and the encouraging words. And thank you for the opportunity to share our goals and progress. And I look forward to some time to tell again about more progress, because it's going to be a very exciting year with exciting events.
Our hour came to an end. We actually overran it. Thank you for staying with us beyond the scheduled time. Today we had a webinar on the precursor mission for human procreation in space. Our panelists were Egbert Edelbrook, the founder and CEO of Spaceborne United. He was telling us about the precursor mission, where there will be the first experiment of fertilization of human cells in space. Stay with us for the news. We expect the flight to take place in April. Professor Dr. Floris Woutz of Antwerp University is the Minister of Science of Asgardia, who gave us the retrospect of the embryology and reproduction research in space, and Mrs. Cheryl Gallagher, who is a performing artist, the painter and the musician, and the Minister of Culture of Asgardia, who shared with us her views on ethical and cultural aspects of human life in space. Follow us on asgardia.space, read our Room magazine, and we are looking forward to welcome you at the upcoming webinars later this year. Goodbye.